Hello students, welcome to another tutorial on static equilibrium. In this video, we're going to work out the question I left you guys with in the previous session. And then we're going to see how best to work it out. There are two methods that you can use to work this question out. One is kind of straightforward and easy, but the other one I think is a little bit more easy to follow. The fact that it is kind of more logical, but both methods are okay. They're very correct. You can use either, the one that you prefer. Okay. Now we're asking for, or the question is asking for how high the man has to climb up a ladder before the ladder slips. Now, in this case, what you have to take into account is for a ladder to slip, it's like you have to kind of pick, let's say, let's look at it in terms of rotations. You kind of have to pick some point. Let's say in this case, we're going to pick the base to say this is the point upon which the rotation has to occur. You can pick any point. So all we want is how high does the person go before, since the force, his weight is pushing down, before the ladder tends to rotate downwards like that, which is anti-clockwise. Now, since these are rotations, obviously they're going to be controlled by the product of force and distance. Now, this is torque. The product, it has to be perpendicular. So this is one thing that is going to determine, to differentiate the two methods that we use, just getting these two to be perpendicular to each other. In one approach, we'll shift the force to be perpendicular to the distance the way it is. And then in the other method, we'll shift the distance. We'll play around with the distance to make sure that it aligns with the way the force is, as in we'll leave the forces exactly the way they are, and then move around with the distance. Okay, so I hope that is clear. So before we move on, the first thing that we're going to do is to assign labels to these forces. So the question already had these forces indicated for us, and let's just assign labels to them so that we know what we're talking about every time when we're working out. So I'm going to use the normal force that is exerted on the ladder by the ground. I'm going to label it as N1. And then this is a force that is acting on the ladder from the ground. So this has to be a frictional force. So I'm going to label it FF. And then this other force here exerted by the wall onto the ladder, pushing it outward. This has to be a normal exerted by the wall. So I'm going to label it as my second normal since I already have my face. These are weights. This is the weight of the ladder. I'm going to label it W1. This is the weight of the man who is climbing the ladder. I'm going to label it as W2. Okay. Now, since the ladder is not supposed to slip, meaning it's not moving, the sum of these forces must equate to 0. That's just obvious. So if we remove that out of the question, what we are saying is that sum of forces, let's start with in the x, sum of forces in the x must equate to 0. So there are two forces that are acting in the x, N2 and force of friction. Now let's take to the right to be positive and to the left to be negative. And then I'm also going to take up to be positive and down to be negative. So in the x, there are two forces, force of friction to the left, N2 to the right. So we have N2 minus force of friction. These must sum up to 0. And then we see clearly that N2 is equal to force of friction. Okay, so how about in the y-axis? What is happening there? So what we are seeing there is sum of forces in the y as well must add up to 0. But what are the forces in the y-axis? We're only seeing 3. We have normal, N1, W1, and W2. So N1 is going up, it becomes positive, N1. W1 and W2 are both negative, they're going down. So you have W1, W2, and these simplify to give us 0. W1 and W2 are given in the equation. This is 200, the weight of the ladder. This is 600, the weight of the man. We get 0. So we add up these, move them the other side. We get N1 is equal to 800. This is a force. it becomes close to Newtons. Okay, once we've done that, we found what N1 is. Now, we're not happy with this force of friction, just the symbol here. There's a way we can find it. Since this is the force of friction at the bottom here, where we know the coefficient of static friction, then you should be able to find it. What do I mean? We know the relationship that the coefficient of static friction is related to the frictional force divided by the normal force. In this case, it is normal 1, which is the normal between the ground and the ladder. So from here, we see that force of friction is equals to normal 1 multiplying the coefficient of static friction. Both we know what they are. We've just found this as 800. And then the coefficient of static friction is given in the equation. That's 0.45. We multiply these and we get 360. And this is still a force, Newton. Okay. Now, since we know what this is, and we come back to forces in the X, we saw that N2 is equivalent to the force of friction. Then it implies that even N2 is also equal to 360 newtons. After doing this, we realize that now we know what all the forces, what these forces are in each case. Now, since we are done with that part, we can move on to our methods, the two methods that we can use to get our answer here. Now, in the first method, we are going to, they all involve talks, really. So we'll just be demonstrating the difference. I'll describe what each one is all about. Okay, so now what we're looking at, let's look at method 1. So for method 1 now, this is talk. So we're going to pick a pivot. So it's going to be the same pivot in each case. So this is going to be true for each case. So we're going to pick the bottom here to be the pivot. Now, after picking this, where are our forces? Well, the first one is at the center here. This is W1. Now remember, the force and the distance, they have to be perpendicular. So in this case, this distance, this force comes straight downwards. This force comes straight downwards up to that point. And then next up, you have the position of the man. We don't really know where this man is really. So we can put him anywhere. So this is W1, this is W2. Okay. Now, lastly, what we have is the position of the last force, which is N2. So N2, let me remove this. I'll write it somewhere at the top. So N2 is somewhere this side. So it is acting from the wall, acting in this direction. Okay. Now in this method, what I'm going to do is I'm going to maintain the length of this ladder. So the dimension of the ladder, I'm going to draw it horizontal this side. Or I can just draw it somewhere here the way it is. So we have the dimension of the ladder like this. What I want to do is to maintain this to be my x-axis. And then anything that is vertical is now moving along my y-axis. Let's start with N2, for example. Let's start with N2. What we notice is N2, according to our plane here, what we are saying is N2 is actually at an angle to this axis. So N2 is in this direction. Now, what we want, or what we are claiming is, this is our x-axis, then this is our y-axis. So what we want is to get the component of N2 that becomes perpendicular to this distance, because the distance we want to work with in this method is the one along the ladder. So since the ladder is in this case, in this dimension, we want to resolve this force so that it gives us a portion that is this side, which is this. So we want to get a component of N2 that is in the y-axis, in our claimed y-axis. I hope you guys are getting this. So now, how do we do that? Well, we need one additional thing if we're going to do that. So we need this part here. So the ladder makes this angle at the bottom. So it makes this angle at the bottom. So this angle, let's call it theta. Now, how do we get it? Once we get this angle theta, we'll easily know exactly what this one is. It's going to be equal to this angle. So how do we get that? Well, we are given two things from the question. If we go back to our diagram, from the question, we are told that the dimensions of the ladder, this is 5 meters, and then the base is 3 meters away from the wall. So we can use the hypotenuse and the adjacent to this angle to find what it is. We're going to use cosine there. So we should be able to say that cos theta is equal to adjacent, which is 3, over hypotenuse, which is 5, and then get the cos inverse of that and show that theta becomes 53.1 degrees. So once we've got that, then you can easily use this angle to resolve this vector so that it gives us a component that we've labeled into y. You guys should be able to see that this will be given by n2 itself sine our angle theta. Why am I saying sine? It's because this angle or this vector is going to be equivalent to this side, which is this side, since opposite sides of a rectangle are equal. So this is how we're going to get it. Now that is for n2. We have to do the same for the other forces. Now, why are we doing that? You might wonder. I think I kind of answered that already. We want to use the fact that torque is equals to force times distance, but the two have to be perpendicular. So since we want the distance to be this, to remain this, so we have to find components of each force which are perpendicular to the distance. So in each case, we want to get here, we've already done it, want to get the components that are in this direction. Even here, want to get the component or the portion of W2 that is in this direction. The same thing here, want to get the component that is in this direction. Notice that since this is theta, even here we have theta, even here we have theta. So I hope you guys are able to see that this component that is in this direction, here it is going to be this direction. This component is going to be W2 cos theta. And then here, this also is going to be, but this one is going to be W1 since this is W1. This is going to be, and write it down here. This is going to be W1 cos theta. So just notice the difference here. If I was to write them on this other diagram here, so one is going to be going down in this way. So we're saying this is W2 cos theta, and then we have the one due to the weight of the ladder, which is going down like that. This is W1 cos theta as well. Okay, so I hope you guys have followed up to this point. Now we're picking this point as our pivot. The whole length of our ruler is 5 meters. Now, how does our problem look now? The weight of the ruler will act towards its center or through its center, meaning the distance from here to here. The whole ruler is 5 meters. This has to be 2.5. Next up, where the man is. Well, we don't know where the man is. That's what we want to find. So I'm going to give it x. This is what we want to find. The distance from our claimed pivot, which is this, or our pivot of choice, to where the man is. So that is x. And then the last force is the one due to n2 in the y. That is going to be the full distance of the ruler, which is of the ladder, sorry, which is the full 5. Okay, now let's get this on the other side and see how we were working it out. So from our our description there. This is our pivot. We only have 3 forces: the component of the weight of the roll of the ladder going down, the component of the weight of the man going in this direction, and the component of the normal from the wall going in this direction. These are the only 3 forces that are causing rotation. Remember, we have ignored the force of friction here and the normal from the ground, because these both forces here are passing through the pivot, and you know any force passing through the pivot has 0 turning effect. So because of that, these 2 are not considered here. Now, how does our expression look like now? So we are summing up the torques and saying that they're equal to 0. What does this imply? So if I say this is torque 1 and this is torque 2, and that is turning effect 3. So we're saying torque 1 plus torque 2 plus the third one, they sum up to 0. So here we observe that these are going, let me use green for this. These are going, since this is our center, these are going anti-clockwise. Even this, it's pulling this ladder anti-clockwise. But this is the only one that is pulling it clockwise. So it's up to us to choose which one we want to take as positive. So I'm going to take anti-clockwise as positive, meaning this becomes positive, positive. This is going to be negative. Okay, so from here, what we have to take into account is, don't forget, these are not really the full forces. We already got the contributions. So to get these torques, for torque 1, we're going to use W1 in Y multiplying D1. So this is positive, it is anti-clockwise. And then next, W2 in Y, and then D2, and then plus. This is now minus, this is clockwise, torque 3 is clockwise. This is going to be N2 in Y multiplying D3. Remember, D3 is the full length of the ladder. So from here, we already saw what W1 in Y was and W2 in Y was. So these, we can substitute them. So this becomes 200. So this is 200, and then cos theta, we already saw what theta was, that's 53.1. So this is times D1, this is 2.5. And then plus, and then we know what W2 is, we already got it as well. So this is the weight of the man, 600. And then this is cos 53 as well. And then D2, we don't know what D2 is. That's the one where we want to find, so we're going to label it X. And then N2Y, we saw how to get it as well. So it is N2 itself. And then this time, we're going to use sine. Okay, so N2, remember what N2 was? That was 360. And then this is sine 53.1. And then this is 5. This is what gives us 0. Okay, so from here, we can simplify these. I think we can easily get them. Yeah, I can easily get what they are. Simplify them and try to work them out. So from here, this can go the other side. So we have 200 cos 53.1, 2.5 plus 600 cos 53.1 x is equal to 360 sine 53.1 multiplying 5. Okay, now for simplicity, when I simplify these, I'm going to write them to two decimal places. Since the answer I want it to also be into two decimal places. So I'll keep writing these to two decimal places. So when I move this to the other side, so that I remain only with this will be 600, yes, cos 53.1 multiplying x. This is now equal to, so the other side, when I simplify this and write it to two decimal places, what I have is 1439 0.43 minus, and then I simplify this and write it to two decimal places. I have 300.21. And then next up, I divide both sides by this. So now I'm going to have x is equals to the same thing. This is 39.43 minus 300.21. This is now divided by 360.25. And then if I work it out from here, I easily get x is equals to 3.16 meters. Okay, so if you guys have paid attention to this, with this method, I get exactly what the position of the man is along the ladder. Notice what I did. Just as I explained earlier on, the goal is to get torque, we multiply force and the perpendicular distance. So you either make the distance to be perpendicular to the force or make the force to be perpendicular to the distance. How do you do that? Get the component of the force which is perpendicular to the distance, or get the component of the distance which is perpendicular to the force. Either method works. So here we just used one method to get the answer. Let's look at how the second method works. Let's see how we do that. For the second method, what we're saying is now we want to play around with the distance. So how does it work? So I'm going to resketch it here. Okay, so let's get our sketch of the problem. I'm going to make it more slanted so that you can easily follow what is happening. Okay, so now we want to maintain the directions of our forces, but all we want, or all we're going to do here is move around the distance so that it becomes perpendicular to the force. So it's up to you which method you want to use. Let's see if they give us the same answer. If you guys feel like you know how to approach it, you can try to use this method and see if you can get it right. The third force is this force which is going in this direction, and this is N2. So just as we did in the previous case, we are going to pick this as the pivot. Okay, now so what you're going to do is, this is the weight of the ladder. We know to say the distance from the pivot to where it is, it's going to be half the full length. The full length from here up to where the pivot is 3 meters. So this has to be 1.5. And then now, how about W2? Well, W2 we do not know. That's what we kind of have to find. When we find this, we can use it to get what the missing one is. So let's label it D. And lastly, to get this force now, notice that this force is horizontal. We can't use this distance. Why? Because the two are horizontal. They're in the same direction. We want them to be perpendicular to each other. So this is where I was saying you have to move around the distances so that regardless of where the force is, they end up being perpendicular. So you kind of have to get the distance which ends up to be perpendicular to this force. So the force is in this direction. So to be perpendicular to that, you kind of have to get the distance which is in this direction. So notice that it is basically just the distance from here to this point. Or you can say it is the distance from here to this point, because again, this is a rectangle and the opposite sides are equal. So if this is 5, and as in all the way from here to the far end, the top part is 5, and from here to the far end is 3, you guys can easily get this using Pythagoras theorem. If this is, let me not use x. If this is h, you guys can show that h is given by the square root of 5 squared minus 3 squared. This is by Pythagoras theorem, and h will come out as 4. So in other words, this is what I'm going to use to evaluate this. Okay, so on that note, so what we're going to have is, if we use the same thing, this is torque 1 and this is torque 2, And from here we get torque 3. So you guys see that torque 1 is equal to W1 times 1.5. Torque 2 is equal to, you can still use the part where we write them, or I just want to write them here so that you guys don't get confused when I go to the next page. Torque 2 is W2 times the distance. We don't know what it is, so we're going to use T. And then torque 3 is equal to the value itself, torque 2, and N2, I mean, multiplying the distance we found 4. That's a distance from where force 2 is to where the pivot is. But then how about directions? Well, clearly you can tell that this is anti-clockwise still, but this is kind of clockwise. So we can choose either direction to be positive. I'll maintain anti-clockwise to be positive, meaning that this is going to end up as negative. So how is it going to look? So now again, summation torque 1 plus torque 2 plus torque 3 is equals to 0. So torque 1, we saw it was W1 times 1.5 plus torque 2, W2 times D. Torque 3 is negative, so that's minus N2 times 4. This is what gives us 0. So I can substitute. W1 is 200, that's the weight of the ladder, times 1.5 plus W2 is 600, so this becomes 600D. I move this to the other side and substitute what N2 is. I end up with 360 by 4. So from here, I can move this to the other side as well. I remain with 600D is equals to 360 by 4 minus 200 by 1.5. From here, I can simplify the right-hand side. I remain with 600D is equal to 1140. Divide both sides by 600. You get D is equals to 1.9 meters. Now, what have you found? What you found is D, which is not the position of the man along the ladder. D is just horizontally. D is here. The position of the man now along the ladder is going to be X, this side. So if I cut it only up to where the man is, I'm saying cut because this continues until when you go to the far top. But D is only up to where the man is, So now we need to get what this X is. This, we found it earlier on. This was 53.1. So we've just seen what D is, 1.9. So meaning we can use cos here. Cos 53.1 is equals to adjacent, which is 1.9, over hypotenuse, which is X. So cross multiply here, we see that X is equals to 1.9 over cos 53.1. And then when you simplify this, you get X is equal to 3.16 meters. So I hope you guys were able to get this. I hope you guys were able to understand this. Both methods give you the same answer. I want you guys to try playing around with this. Pick which method you feel you understand best. They will both work. Okay. Now, this has already been a long discussion. So what I want you guys to do, just for you guys to practice, I want you guys to try out this question. So let's see how you're going to fare with this question. So I found this question in a past test paper. It carried a whole 13 marks. So try it out, see how you find it. It's kind of similar, but a little bit different, but the approach is pretty much the same. I want you guys to try it out, see what you get. You can leave your answers in the comment section, and then I'll comment there if no one does. I'll comment if your answer is correct and so on. And then if you struggle, well, just keep on trying. And then if you feel like it's becoming too much, you can then get in touch with me. I should be able to help you. I can connect you to one of my live classes and show you how to work this one out. My email is going to be in the description if you want to join one of my live classes. Okay, otherwise, in the next video, we're going to work on the next question, which is this one. You guys are free to try it out before our class or before my presentation. Otherwise, this has already been long. This was your tutor. Hope this was helpful. See you next time.